Okay, so we're going to factor this binomial. So the first type of factoring you should always try to accomplish with any factoring problem is pulling out a greatest common factor. So I want to look at my terms. There are two terms here. 5a squared b is the first term. The second term is 6a squared c. So the 5 and the 6 do not have any common factors other than 1. 5 is a prime number. 1 times 5 is the only way to break it down. 6 is a composite number. 1 times 6 or 2 times 3 are the only ways we can break that one down. So there are no common factors in the 5 or the 6. The only thing I see in common is the letter A, and it happens to be squared in both terms. So our greatest common factor is A squared, leaving inside the parentheses 5b plus 6c. And that is as far as this problem can be factored. So that is our result for this factoring problem. Let's try another one. 9x cubed y squared z plus 18x y cubed z cubed. So again, we want to figure out what is in common first. So we have a 9 and we have an 18. Well, since 18 is 9 times 2, these two terms share a factor of 9. So we will take out a 9. Now we have the letter x in both places. In the first term, we have 3 factors of x. In the second term, there is only 1 factor of x. There is an understood 1. So we can pull out or factor out 1 factor of x. The letter y appears in both terms. In the first term, there are 2 factors of y. In the second term, there are 3 factors of y. So what's in common, what's shared, is 2 factors of y. There is also a letter z in both terms. We have z to a first power, so 1 factor of z in the first term, and 3 factors of z in the second term. So what is in common is just the 1 factor of z. So now we figure out what's left inside the parentheses after we pull out this greatest common factor, because our greatest common factor is 9x y squared z. So from the first term, we would have x squared, because there were 3 factors of x. We have factored out 1 factor of x, so that leaves 2 factors of x. There is also a 1 left from the 9. If you want to write the 1, that's okay, but it is not necessary to write the 1. It's understood to be there whether we write it or not. The factors of y, we started with 2 factors of y in that first term. We have factored out 2 factors of y, so there is no y left. There'd be y to a 0 if you wanted to write it down, but again, that's unnecessary. And the z to a first power, we have pulled 1 factor of z out. So the only thing left from that first term that needs to be inside the parentheses is x squared, or 1x squared if you want to write the 1. And then from the second term, So we have the plus sign still. From the second term, 18 divided by that 9 leaves us with a 2 for the coefficient. The x to a first power, we factored out x to a first power. Y cubed, we started with 3 factors of y in the second term. We have factored out 2 factors of y, so that leaves one of them. And z cubed, we had 3 factors of z. We've factored 1 factor of z out, so that leaves 2 factors of z. So we have successfully factored out the greatest common factor, and that's all that can be done with this particular problem. Let's do one more of this type of factoring. Let's make it a little bit more complicated. 48 b squared c to the 6th minus 144 b to the 6th. Let's make a better looking 6th than that. B to the 6th, c to the 8th, minus 192 b to the 8th, c to the 9th. So when we have numbers that are this large, we may have to figure out the factorization of those numbers so that we can successfully factor it. So let's go off over to the side here and make this a little bit smaller. I made this a little bit smaller so I can do this. So 48, just looking at the numbers, the coefficients, 48 breaks down as 6 times 8. 6 is 2 times 3. 8 is 2 times 4. And the 4 will break further down into 2 times 2. So 48 could be thought of as 2 to the 4th power times 3. We have 4 factors of 2 and 1 factor of 3. Now let's do the same thing with the 144 and the 192. So I'm going to make this a little smaller so I have a little more room. So 144 is 12 times 12, and 12, each factor of 12 breaks down into 4 times 3. And each of those 4s breaks down into 2 times 2. So that will give us 4 factors of 2 and 2 factors of 3. So that gives us 2 to the 4th times 3 squared for the 144. 192 is 12 times 16, and 12 is 4 times 3. 16 is 4 times 4, and each one of those 4s breaks down into 2 times 2. So that means that 192 factors into 1, 2, 3, 4, 5, 6 2's and 1 3. So 192 is 2 to the 6th times 3 to the first power. So we could write this out as 2 to the 4th times 3, b squared c to the 6th minus 2 to the 4th times 3 squared b to the 6th c to the 8th minus minus, we know what 192 is now. 192 is 2 to the 6th times 3, b to the 8th, c to the 9th. So if the numbers are large enough, you might want to break it down this way if you find it helpful. So when I look at the factors of 2, I have 4 factors of 2 in the first two terms and 6 factors of 2 in the third. So what is shared in all three is 4 factors of 2. So 2 to the 4th is a common factor throughout the problem. Now the 3's, we have 1 factor of 3 in the first term, 2 factors of 3 in the second, and 1 factor of 3 in the third. So 1 factor of 3 can be pulled out. For the letter B, we have 2 factors of B in the first term, and that's all that can be pulled out because that's all that is shared in all 3 terms. And for C, we can take out 6 factors of C because that's what's available in the first term. And so now we just write down what's left behind. So in the first term, we have pulled out all factors of 2 that were there, all of the 3's, all of the B's, and all of the C's. So what's left? Well, remember, when you're factoring, you're dividing. So when I divide that first term by what we're pulling out, all that's left is 1. So minus then, from the second term, the factors of 2 have all been pulled out, but there is 1 additional factor of 3 inside the parentheses. There are 4 factors of B inside the parentheses, and there are 2 factors of C, because we had 8 factors of C, and we're taking 6 factors of C out. And then minus the third term, what's left? Well, there are 2 factors of 2, because we had 6, we've taken 4 out. The 3 is completely pulled out. B, there would be 6 factors of B remaining, and 3 factors of C remaining, and then we close our parentheses. And that's it for that one. And that is about as complicated as a greatest common factor problem is likely to get. So let's move on to a different type of factoring in the next video.